how these blocks has to be used. Okay, so here you can, first block which we will always use is simulink block. So simulink block consists of so many sub blocks. Okay, we will see one by one what is a simulink is, what all is there inside a simulink, and what and all is required for us to work as an electrical and electronics. This Matlab is wide open for all the departments. Okay, it is not specific for electrical or electronics. It is wide open. So let us look at into our point of view alone. So we need to know about something with the simulink. Then you must know something with related to SIMscape. Even you can take down, that is called as SIMscape. So simulink block and SIMscape block are required for our process. Okay, so I will go back. I will show with respect to Matlab itself. So I have told you can open. So this is what we call it as command window. There I go to new. Then I will click a new block. So a new block has come in the name of Untitled one. So here you just click this. This is called as library browser. Okay. So when you stick your library browser, so I told I will explain one by one. So this is called a simulink, and we usually use the blocks here. So which we call it as commonly used blocks. This commonly used blocks, when you want to give an input as a constant value, use this constant block, and gain block is to multiply for something. When you are going to add two things, you use sum blocks, and terminate is unwanted things we can terminate. So all these things are available, and I think you all know what is relation operator, logical operator. All this will be used for generating pulse. Okay, then the main remaining person is scope. Scope is similar to your oscilloscope in your lab. You will connect it and try to see your simulated output. So there is scope and X graph. Both this we will use today. I will show you how to use. And this display block is just I want to know the final value alone. I don't want to see the graph. Then you use this display. Okay. Then comes your source. There are so many types of sources. Namely, if you want to, I think you all know what is MOSFET, what is an IGBT, what is an SCR, and all these are semiconductor devices. All these semiconductor devices require an input pulse. So when you give pulse, the device get turned on, and when you remove the pulse, the device will off. That depending upon the device we are going to take. If it is an SCR, there is a separate way of giving firing pulse. If it is MOSFET, then it is a separate way of giving firing pulse. Okay, how to give this firing pulse is use this block called pulse generator. So I think you can see this, a block named as pulse generator, which this we will give your pulse. So in today's session, we will talk about pulse generator. Then we will talk about ramp. Okay, what is a ramp source? How you are going to give this ramp source? Okay, so this two we will try to see. Then you move on to, I have told that another block set which is used is SIMscape. Okay, so SIMscape is the block which we will use. When you click on this SIMscape, you will see that foundation library, then SIM drives, SIM electronics, SIM power electronics, and utilities. There is one thing in Matlab is when you are using two block set, you cannot directly connect. So you have to interface with something for interconnecting the two different block set. So for that you have something called utilities. So with the help of this utility blocks, like connecting simulink to SIMscape, SIMscape to simulink, and then solvers. And one more thing I like to say is Matlab works on matrix, I told. So for matrix, I think you all know there are various methods for solving matrix, like Renagunda, Euler, and so many methods that we call here it as solver. So whenever in Matlab, if somebody says something called a solver, you don't want to get afraid. The solvers are nothing but how you are going to solve the matrix. So there will be a separate solver for simulink, and there will be a separate solver for SIMscape. So you should know to connect the corresponding solvers so as to solve. Okay, then today I think I told that we will see with respect to solar panels. So when you want to see with the solar panels, then you should know where that solar cell is present. So solar cell is in SIMscape, in SIM electronics, you have source. In that source, you have a person called solar cell. Okay, so from here we will take the required solar cell and we will try to simulate. Then SIM power system is the block which is required for us. and specialized technologies. Under that you have so many subdivisions. So this is the main thing. If you want, even you can take down in SIMscape under SIM power system. Under that it is specialized technology. Okay, in that when you see there are elements, we know what and all the elements like inductor, capacitor, resistor, grounding, various types of grounding, transformer, all these comes under elements. And in our simulation today we will use branch and load, series RLC and series RLC as a load. Okay, then source we all know it is AC source, DC source, battery. Then you have an DC source, voltage source, and battery. There is difference. This is limited, this is an infinite source. So you can draw a huge amount where battery will get drained off. Okay, then when you are going to convert it into some variables and then again regenerate source, we will go for control voltage source and current source. So in our today's session we will discuss with, first we will discuss with the DC source, then we will go for even control source. Okay, so I have told what is element, then what is source I have told, then machines. This is our major part, even though we doesn't touch today. There are so many machines like permanent magnet, synchronous generator, switch reluctance motor, stepper motor, then your all type of AC machines and then DC machines, all that's are available. Then measurements, we all know that we used multimeters. So with the help of multimeter we try to measure voltage and current. Similarly in Matlab, to measure voltage and current you have a block called voltage measurement and current measurement. If sometimes my voice is not audible, you can tell me. I think my voice is now clear. Can I proceed? Hello?
Perfect, Vinod, you can proceed.
Yeah. Okay, sir. Thank you. If there is any difficulties, then if you tell, then I can go ahead. Okay. So we have seen till measurements. So it is V measurement blocks is there and I measurement block is there. And then moving into the next person who is called as power electronic devices. We all know there are so many types of devices like MOSFET, IGBT. We preferably go for either MOSFETs or IGBT because they are high voltage and high current device which are voltage controlled. So whenever you want you can turn on and turn off. There is some difficulty with current control device. We all know that current control device can be only turned on, cannot be turned off. So they can be used only in a circuit where you convert AC to DC. Okay, vice versa is not possible because DC current will not come to zero at all. So no current control device can be utilized. So in all DC circuits, you will go only for voltage control device, and the voltage control device are MOSFETs and IGBT. So then that utility I have already told. So now we can let us start. So the first what I am going to show is your boost converter. So how to going to simulate this boost converter. So when you see this boost converter, there is a source, you have a DC source, then you have an inductor, then you have a switch. This switch is MOSFET. I think symbol and all you are clear. This is what type of MOSFET is. It is enhancement type, which means normally the switch will be in off. When you give gate pulse, the switch will be turned on. So that is why there is some dash in between, that the second line is not totally completed. So there is a break. So there won't be any path between drain to source. Only by giving pulse, there will be a path between drain to source. Okay. So MOSFET is the device we are taking. So now there is two conditions, when switch is off and when switch is on. Okay. When switch is off, your source is going to is going to go for diode and charge the capacitor. So it will get charged for your supply voltage Vs. When switch is on, what happens is your source plus inductor alone come into picture and this inductor gets charged. So when switch is off, source plus inductor, so it will go to twice. So that is why the name boost. Okay. In AC we don't have any problem. We have a transformer based upon the primary secondary winding. You can step up or step down. Whereas in case of DC, we cannot use transformer because they will go to saturation and there won't be any from primary side to secondary side. So transformers cannot be used. So only option is you have to go for power electronics based converter circuit. Okay. So I like to share something which is called as, when you say a boost converter, you step up voltage. Okay. Stepping up power is not at all possible. power remains constant. So what is there in the input side can only be come to our output side, and nothing can be increased or decrease will be there if there is any loss. Okay, so a boost converter is a DC to DC converter that steps up voltage. So the thing you have to notice, since power remains constant, if you increase the voltage, obviously your current will come down. Okay, so you should know that only any one person can be stepped up. If you step up one person, obviously the another person will come down. Okay, so output equation is given by V out by V in is equal to 1 divided by 1 minus D. Now you should know what is called as D. D is nothing but duty cycle. Duty cycle is nothing but how much time you are going to turn on this fellow, that we call it as duty cycle. Whether 10% duty cycle means out of 100%, only 10% is on and the remaining percent is off. See, since we want continuous output, we will go for continuous conduction mode and we doesn't go for discontinuous conduction. So the switch should be operated at very high frequency. All this you can visualize when I go for simulation. There I will tell you. So you have to operate this fellow at high frequency. Okay. So just I am giving an example. Assume that your boost converter is operated for 80% of the duty cycle, which means 80% is turn on and 20% is turn off, which is nothing but 0.8. Okay, 0.8% it is on. So what will be the output? Output will be V in divided by 1 minus D. 1 minus D is nothing but 0.8. We are operating, so it will become 0.2. So I am assuming input voltage to be 96. I will tell the reason why I am using 96 and all when you go for simulation, so that you can understand it clear. So 96 divided by 0.2 will be around 480 volts. So that is why we call it as boost converter. So from 96 volts, we are able to step up to 480. And the thing again you should notice, the limit is still 0.8. So you cannot assume 0.9, 0.999, that and all you cannot assume because we cannot generate pulse. Okay. So now let us move on to the next one. So what is component required? So to simulate this particular boost converter, what and all blocks is required from Matlab? So that is what I am showing in this slide. So I should need a DC voltage source. That is the first thing. Then I should need a device that I am choosing as MOSFET. Then I should have a person called diode. Then I should have some inductors and capacitors. For that I have taken this. And this pulse generator is going to give pulse to this MOSFET. Okay. Then voltage measurement and current measurement. With that you are going to give it to scope and see. Okay. Okay. So let us move on to Matlab. So now come to this Untitled. So what and all we should go and take? I have told you have to take first source. So source, I repeat, go to SIMscape. Okay. In SIMscape there is an electrical source. In this electrical source, I want to take this DC voltage source. Just right click it, say whatever you want, just right click it. It will show add to Untitled one. You say yes. So automatically it will come and be placed in this particular screen, which we have named it as Untitled one, or I have not saved it till now. Okay, so I have taken my DC source. The next component which I require is your MOSFET. So go to power electronics. So in power electronics, I told there is MOSFET. Just right click, it will say add to Untitled. So I have added, then I am bringing it here. Okay. Then what I want an inductor. So how to take this inductor? Again, go to elements. So in you have RLC branch, add this to Untitled. I want only inductor. So what I will do is just double click. Now left click you have to do. When you do your left click, automatically it will show RLC or RL, what you want. Just click it as L. Just I am taking it as 30 millihenry. Okay, so it will automatically change it to L. Okay. Now this I have to rotate. So for rotate in Matlab, you have to press Ctrl R. If you do Ctrl R, it will rotate. We all know that drain should be at higher potential with respect to source. Okay. So from source, I am connecting into my L. Then from there, I am connecting to my drain. Then from source, I am connecting into the negative of my DC source. So this is one path. Okay, one path is completed. So next what we want is, we want a diode. Okay, again go back to this library. Again go back to the power electronics. There you have this person called diode. Just right click it, then say add. Okay, it will be here. Now just add it to this particular thing. Okay, now what is our next step? So what we have to connect next, tell me. So next we have completed, taken DC source, we have taken an inductor, we have taken a switch, we have taken a diode. The remaining is your capacitance and load. Okay, so let us draw it. So you need a capacitor. Just right click and drag. If you right click and drag, you will get one more thing. Just drag it. Now you change it from L to C. Okay, now it is asking the value of capacitance. I am writing it as 1500 microfarad. Okay, so again to rotate, I repeat, you have to press Ctrl R. So once if you press Ctrl R, then it will rotate. Now connect it to diode. Okay, so you have completed to certain level. The next thing is you need load. Just again right click and drag. If you right click and drag, you will get one more. Now you have to change it to R. Okay, so put it in R. You put some whatever value you want. So that is, I have put as 15 ohms. So I am connecting this load here. So now your circuit is over. Only thing what you have to do is, you have to give the gate pulse to the MOSFET. So for this, what I have told, you should go for pulse generator. And I again repeat, it is there inside the simulink. In simulink, when you go to source, in the source you have this pulse generator. So just add it. Now comes your picture. I think all third year students might have studied power electronics. Now you have to just take down this, go to the inside this pulse generator block. I repeat, just to double click, left click. Okay, it will open. Now you have to tell what is the amplitude is, what is the voltage required to turn on your MOSFET. So we all know it is VTH, minimum gate turn on voltage. So it is around 8 volts. So let us give 12 volts. Okay. Then period. Period is nothing but T on plus T off. It is asking in terms of time, not in terms of frequency. So let us assume I am operating this converter at a 25 kilohertz frequency. So 1 by 25 kilohertz frequency I should enter. So obviously it will be in some decimal value. So I am putting it as 0004. Okay, so this is the frequency at which I am operating. I repeat, it is 1 by of f, because it is asking in terms of second. It is not asking in terms of frequency. Okay, so I have entered. Now pulse width. Pulse width is nothing but the duty cycle. Okay, now let us start with, say I am putting 40. So it is going to boost 40%. So duty cycle is 40 now. D is 40. Now we have drawn the circuit. The next thing what you have to do is, I told you should have connect a person called the solver. So in our case, now solver is power GUI. If you want, you can type it here also. So if you are fresher, sir, I can't remember each and everything. So what I do, sir? So nothing to worry. Just type it as power here. See, you are able to see power GUI. So just add this block. This block should not be connected to anything. Just this block should be kept, so that it is for solving this. This person will try to help. It is like similar to an header file in C++. So this is an header. So if you added this header, then Matlab will understand all the blocks. Okay. Next step is what we have to do. We have to measure this voltage and current. So when you have to measure this voltage and current, I have told something called as measurement blocks. Where it is, again you have to go to SimScape. In SimScape, Sim Power System. In Power System, you can able to see measurement. So take down I measurement and take down voltage measurement block. So just right clicking and taking. We all know how to measure your current. Current should be measured. Sorry for the disturbance. Yeah, just I will take it out. Delete. Then again I am reconnecting. So I have connected. And now you all know that how to measure current. Current should be measured in series. So you break this path So you try to connect it. So this is how you have to connect your current measurement block. Current should be always measured in series. So I am cutting a path and intermediately I am trying to add this current measurement block. Similarly, your voltage measurement block should be connected in parallel. So I am trying to connect it parallel. Okay. Now what is our step? We want a CRO or we want to see the graph. So again I repeat, you have to go to simulink. Okay, in simulink you have a person called sync. In the sync you have a person called scope. So add to this. So we have added your sync. So connect it to your current as well as to your voltage. So how I am doing this? I will repeat. Just right click it, then drag. When you right click and drag, you will get this current measurement block and voltage measurement block. Okay, now everything is ready. You can simulate. So if a Matlab doesn't require to save and run, but it is advised you can save it. So I like to save it as a boost converter. So I am giving name as boost. There is no space is allowed. So you can go for underscore. You cannot give any space in naming in Matlab. So I am saving it as boost converter. Okay, now your converter has been saved. Now we can simulate. To simulate, you are able to see this green icon, run icon. So just press it. So once you press it, it starts running now. Now the converter is being simulated. And total seconds I have given here is 10 seconds. See, if they ask for 15 seconds or 20 seconds, whatever you want, you can enter here. Now I am just entered at 10. So first of all, I will tell you, I doesn't disturb duty cycle. So I just allowed it to run. So okay, now I think time around 4.5 seconds is over. So we have to wait till it reaches 10 seconds. So once it reaches 10 seconds, then you can see the entire simulation output. Okay. So now what we have kept as 100 volts. Okay, input as 100 volts. I have not changed it. Whatever value you can want, you can change it. So 100 I have kept, and I have kept at 40%. So what will be the output? Output will be for 100 divided by 1 minus D, and 1 minus D is 0.6. So 100 divided by 0.6 will be your output. Okay. So now we can view it here. So maximize it and try to view. Now there is a problem. What is the problem? See, it is showing from around 9.99 to 10. So it is not showing from 0. This you have to change, because you want the output from 0 to 10, not from the value of 9.9 to 10. So what you have to do is, you have to go here, go to history and take this. Okay, all this is the thing, small things you have to note, because no one will tell why that is not coming. So just go to history, then there will be a tick mark. See, it is saying limit data point to last 5000, but I doesn't want to stick on with the last 5000 value. I want the values from 0 to last the value. So I am unticking. Then again, there is another way of presenting this output, that with the help of Workspace I have told. So now please tick this, save the data to the Workspace, and you have to give the name. So what I am going to give the name it as, capital B is for boost, and what we are measuring is voltage. So I am writing it as BV, capital BV. Then apply. Again you have to simulate, because once it has simulated and shown the output, so it has shown only last output. No, I want from the first. So now again I am simulating. So now you can visualize that it is again simulating from the first. So again let us wait. It has now around 2 seconds it has simulated. So we have to wait for 10 seconds. So after 10 seconds we can view the output waveform. So we will wait for a few seconds. Okay, already it has come to 4, around 47%. Intermediately at the time of running also you can go and see your graph, but it will not show the entire, it will show the current location. See, it is now crossing around 7 seconds. So it is showing as some yellow lines. But when you go for any presentations or presenting this in any paper or a conference, then displaying this figure will not be good. Like see, in a background, when you display in yellow and all, it is not good. So this is my output. Now can you see the difference? It has started from 0, it has some overshoot, it went on some overshoot, then it settled at a particular value, then it remains constant. Okay, now what shall we do? Now let us again re-simulate it, and during the simulation let me change the value of duty cycle and try to see what is happening. Okay, so I am again re-simulating it. Okay, so simulation has started. So now I am waiting, let it come for 1 second. So once it's come to 1 second, now what I am doing is I am increasing my duty cycle, which means from 40 to 50 I am done. So again I will wait for few, let it come for 3.5. Once it come for 3.5, so again I will change it from 50 to 60. Okay, then again let us wait, it has come to 6. Once it comes to 6, okay, I am changing my duty. This all I am doing just to show you what will happen to the output. I am go on changing my duty cycle again at 8. I am going to change my duty cycle. So I will change it as 80%. So starting from 40, we have changed our the duty cycle. So by changing the duty cycle, what should happen? The voltage should increase. See, it is a boost converter. When you go on increase your D, what will happen? The boost will increase. So now when you see this graph, are you able to understand what I have done? So initially it has started it with a cycle of 40. Then I have increased the duty cycle to 50, then 60, then 70, then 80. Now the voltage, what you have given input is 100 volts, and what has been your output is around 450 volts. It is around 430. You can zoom and all you can do. See, if you want to zoom and see, you can zoom it so that that part alone we can see. Again, this is called auto scale. When you press this, your picture will come to back. Okay, so you can do both horizontal and vertical zoom is possible. Okay, now I will tell you, see, this is in black background with the yellow color. This is not awkward. This look awkward if you put it in your Word file or your presentation. So what we will do, I will tell you how to do. That is with an help of instruction called plot. Please take down note of it. Take note as a instruction called plot. So I am coming to command window. I told you when you want to write anything like instruction and do, you have to come to this person called command window. Now I am writing instruction as plot. So plot, then within bracket, what I have to plot, I have to first identify. So now I am going to plot a value called SV. Okay, so SV is nothing, sorry, what is the value which we have given? Go to our slide, see what is this is voltage. What is the name we have given? The name we have given it as BV. Okay, and that you can see in command window. There will be a person named with BV. Okay, so now plot BV. So plot BV, capital B, capital V dot. I want x-axis as time, so I am giving it as time, then comma, then y-axis I required the value of voltage that is stored in Workspace as signals dot values. So it will be signals dot values. So if you want, I will show you. See here, just touch here in Workspace. If you double click, then it will show what is, see, one is called as time, another one is signal. Just double click on signal, you will see values. See, so much values is being stored. Okay, now just press enter. Okay, VB is the thing which we want to see. Sorry, this is not the instruction. We write it as BV is the which we want to plot. Then press enter. So this how this will. So what is the advantage of going by this method is, once you have written this instruction plot and got this figure, you can just save this figure itself separately. Then for your future purpose, you don't have to open your circuit, simulate, then get the data and all. Okay. Now I will tell you what and all decoration can be done here. Go to this insert column. You can insert X label. X label is nothing but time. So write it as time within bracket. You write it as second. Okay. Again go to insert column. I have done X label, now Y label. Y is nothing but voltage. So write it as voltage within bracket units, that is volts. Just click it, automatically it will get rotated. So now if you want, even you can put heading also. So heading you can put it as title. Okay. So in title, what you have to write? You have to write output voltage of boost converter. So you write it as output voltage of boost converter. So once if you write it, then that name will be saved. Now I should write something to say that what is this value, what is this value, what is the change. So what you can do is go add a text box. So text box, if you add, please wait, it takes some time. It will display a box here. Insert a text box. So it will insert a text box where you can see what you can do is you bring it here, you can write it as D. Sorry, I will go there. Yeah. You can write it D. Sorry, again it is coming out, just 1 minute. Yeah. It is in, rather than entering, it is entering here. Okay. I will go there. I will maximize it so that that will not disturb us. So you write it as D equal to 40. And again this box I don't want. So what I can do is go here. Okay. Then line style is there. I am saying none. So if I say none, so now it is appearing as D40. So similarly what you can do, you can write it as each and every value. So take it, bring it here. Now this is waveform which is obtained for duty cycle of 50. Okay. So here you can write it as 50. So similarly what you can do, you can write it for so you can place it here. I am writing it as 50, and similarly you can write it there as 60 and so on. Control C. Just I am doing Control C and Control V. Don't want to go there and say again insert and then move it, and then that and all is not required. Just you do Control C and Control V. So here duty cycle is around 60. So you can do like this. So your entire appearance will be so good. And finally what you can do is you can directly save. So you can save it and keep it as a separate like output files. So all outputs can be separately stored. Then further you doesn't want to run your file at all. So you can write save it as voltage output of boost converter. So for further reference, you doesn't want to go and simulate. Here I can put a space, there is no problem. So voltage output of boost converter. Just if you want, I can save it in desktop. Okay, just save. So this file will be saved. So directly you can open this file at any time and you can alter. That is the main advantage. See, I have saved it, closed it. I'm opening after 5 or 6 days. Then I think, why can't you write the year 70 and you can write 80 here? That can also be done. Okay, and it is very easy to bring it to any other file. So just copy figure. So once you've copied it, so if you want to place it in Word file, I will show you. It will be very pleasant to see and it will be very good. So just when you want to prepare any PPT or when you want to prepare any document for your college or when you want to do any paper presentation, for that you have to have this file in your Word. So what you can do directly, you can come to Word, then Control V, you will get this image. Okay, so even I have shown the same simulation file in my presentation also. So this is with a single duty cycle. I have not changed the duty cycle. I have compared with input voltage and output. So when there is 2% in the graph, you need a legend. The legend will tell about what is each. Blue line is input voltage and green line is output voltage. How to do this is, go to the figure. So go to insert. In insert there is a person called legend, and since now you have only one value, it is showing only one. You can combine two also. Okay, so if in the same graph, if you want to see current waveform, that can also be done. See, what we have to do is, what we have stored as a current is stored in name called as, I think, capital BC. We will see the diagram, then we will know what is the name we have given for current. Current we have given name as, oh sorry, we have not given the name. No problem, let us give the name and then we will write. I will give it as BI. Okay, only thing is, when you have not given the name, and if I do now, the thing what you have to do is, you have to again simulate it, only that is required. Okay, so no problem, just to show you I will do it. And once again I am simulating. Now I am not disturbing any duty cycle, so my current will be a single current. Okay, if you want, if you have done previously before your simulation, then you what and all disturbance you given on this pulse generator will reflect on both voltage and current. But now since I am not disturbing, because I want to see what is the current value, so I am just giving it as value and then waiting. So I have to wait till 10 seconds. So we have to wait till 10 seconds. So at the end of 10 seconds, I will get the current value. Even now at the time of runtime also, you see what is your current. Current is around 29 amps. It is coming out. So your resistance, what you have put in, is drawing this much amount of current. Okay, don't think your source is delivering. Source can deliver n amount of current. Current is always dependent on load. Load decides your current. Your current is not decided by your source. Always current is decided by the load. What you draw is the current. Okay, so your resistance is drawing this much amount of current. Okay, so it has come to 6 seconds. Let us wait. It will come to 10 and it will complete. So once it's come to 10, we can see what is the current. Okay, so now simulation is over. Then when you put it, you see approximately less than 29 amps. So now why I have simulated this is to show you how to insert second fellow. Okay, so go here. So now I think it is coming here, BI in Workspace. I think all are clear that you can see that in Workspace your name came here as BI, which is telling the current. So just go here, repeat this, just copy this what I have entered, just copy, Control C, then put a comma, then you try to paste it, change it as VI as caps I have written, so you have to write capital letter here, so it is BI. Now what I have done is, I have going to plot both voltage and current. Okay, then press enter. So if you press enter, now you can see in figure there will be two lines. Okay, now what is the change which is happening is, last time we have changed for various duty cycle and now I have not touched the duty cycle, so it is reaching its final value. It is coming to what is the max. So last time we have done for lastly we kept the duty cycle as 80%. So for the 80% duty cycle you got the output around 430. So this is value. Now all these fellows are not needed, so just select it, delete it, select key, delete key. Now there is two waveform. So when you put it in a paper, there will be a question, what is this blue line and what is this yellow line? So now what you have to do is go to insert, then you insert legend. So legend will appear. Now you can write it here. See, then once if you are written here, nobody will ask what is each and every. So V is nothing but output voltage, and your green line is saying that it is output current. So it is very wonderful that you don't want to have two graph and all. See, when you do simulation, see, this is a separate scope which shows only current, and this is a separate scope which shows only voltage. But now we are able to combine these two and show it in a single graph. So now just you can insert again. You can insert X label. X label is time. Within bracket you can write it as seconds. Again you can insert Y label. So Y label is nothing but voltage and current. So you write it as voltage, comma, you can write it as current. So you say that Y axis is common for both voltage and current. I am writing with respect to units, that's all. Okay, this is what you are getting. Again you can save it, you can use it, or if you want, see, just go here, copy figure, put it in your Word file. That's all. So it is very easy. Control V. Just if you do Control V, it will be there. You can zoom it so that you can even have a clear view. Whatever you want to process, you can process in Word file. It will be very clear. So that is what I am showing here also. So when you see it as a PPT presentation, we can visualize. So this is voltage waveform and this is current waveform. Okay. So this is for various duty cycle. Only voltage alone I have shown. So starting from 45 duty cycle, 50, 60, 70, 75 and 80. Okay, now let us move on to simulation of solar panel. This is the second part of our today's presentation. I think till now we are able to understand. Do you have any doubts? Can I proceed? Finally, we will have a doubt session. So that shall I proceed?
Yes, Vinod.
Yes, Vinod. Yes.
So, yeah, second part, what we are going is with respect to solar panel design. Okay, nowadays everywhere we see it is renewable energy. Renewable energy is the talk, and the future will be only on renewable energy. There won't be any conventional fuels where it is going to exist. So we all should move towards renewable energy. So you should have an idea of what is a solar cell, how to design a solar panel and all. So here I am showing two figures. Left hand is solar cell. Cell is a single block. That cell will be able to provide around 8.5 amps and 0.6 volts. Okay, so to get the required voltage, what we will do is we will seriously connect this solar cells to form a solar panel. Okay, you will have a cardboard structure over which we will try to place the glass. Over this silicon structure will be very thin. Silicon structure will be placed, and again 1 or 2 sheets of glass and then frame. So finally we will get it as a solar panel. So this is how this appear. And one more thing I like to say is solar panels are available in 3 forms. We say it as monocrystalline, polycrystalline and nanocrystalline. So when you go for high efficient panel, if you want, you have to go for monocrystalline. If it is polycrystalline, the efficiency is less. Nanocrystalline is efficiency is some more less, but the advantage of going for moving from monocrystalline is it is cheaper. Monocrystalline panels are costly, other panels are cheaper. Now you go for a specification in net. So before simulation, let us start by saying what you are going to simulate. So I am going to simulate a solar panel. So specification of solar panel you should know. So when you see a specification, this is what I am showing is a 250 watt solar panel. So 250 watt solar panel I am showing here. So for this 250 watt solar panel, there is something called open circuit voltage, which is 37.25. So which means when you are not giving any load, just by putting a multi-voltmeter and measuring the voltage, you are able to measure 37.25. So this is the voltage which is coming from solar panel. We should be very clear, this is not the operating voltage. Operating voltage is somewhat different. When you connect a load, voltage will drop. So you should know what is the resistance that should be connected to get a maximum V and I. So that is what we are going to simulate using Matlab. Okay, next is, you should all know what is short circuit current. See, they are writing it as 8.95 amps, which means it cannot deliver 8.59 amps to the load. What they are saying is short circuit, which means resistance is zero. No load will have a resistance of zero. So if a load is with the resistance of zero, it says it is 8.5. So maximum current, and this is maximum voltage. Now, I have told a solar panel is made up of solar cells, and you have to connect it in series. So each solar cell is going to deliver 0.6 volt. So you divide 37.25 divided by 0.6. So you will have a conclusion of how many cells you want. So it will come around 62 cells. So you have to take 62 individual cells like this. Individual cells you have to take 62. Individual cells like this 62 you have to take. You have to connect all that in series. When you connect in series, you get a voltage of 37.25. Again I repeat, this is open circuit voltage. When you give load, automatically it will reduce. Okay. Now let us see, for simulation of solar panel, what and all blocks are required. So you can take down what and all blocks are required. First and foremost block is I need solar cell. So solar cell, then this, with the help of this solar cell, I will go on add and I will try to generate to required voltage. Okay, so then the remaining block, since this is from Simscape, I cannot directly connect to Simlink, so I should need a person called PS Simlink converter as well as S to PS. So PS to S and S to PS is required, and Simscape will work with a different solver. So there we have used Power GUI. Here we should use a person called solver configuration. This is for solving the Simscape block. Okay, this constant block is there in Simlink. This voltage and current measurement, see current sensor and voltage sensor, I will say where all these components are there so that you can get familiar, and I will say about ramp, variable roads, product and all. Okay, so let us move on to Matlab again. So from the presentation, let us move on to, so I will just delete it and I will show, or I will go with a new file. Okay, no problem, go new model file. Okay, bring it here. See, I will try to put all the component, but I have already simulated and kept it. I will go to that file finally. Okay, but just I will first tell you where each and every block is. Okay, now first fellow, what you want is a person called solar cell. So you have to go to Simscape. In Simscape, you have to go to Sim Electronics. In Sim Electronics, you have a source. In that source, you have this solar cell. Okay, take it and place it in your Simlink file. Okay, so I have dropped it. Now you are able to see there is three output. This is one output, this is one output, and this is an input. So you all know what is solar cell. Solar cell will convert solar energy into electrical energy. You are not supposed to say it is light energy. Light energy is not converted. Energy from the sun, which is in the form of photon. Okay, photon. So each and every object in universe has a wavelength for photon. You all know sun is of yellow light maximum. So yellow light has an photon of 1000. Okay, radians per second. So this is about your solar cell. So that you have to give it here. What is the radiance of you are going to give, that you have to connect it here. So I told you have to connect it to series. Just right click, drag, right click, drag, right click and drag. So 1, 2, 3, 4, 5. Okay, like this what you have to do is you have to go for 62. Okay, but just I will show how to connect this, and I will go to the simulation which I have already done so that you can visualize there better. Okay, so from this negative, connect connected to positive. Series I told it is not parallel. So one output should be given to the next person input. Okay. Again this negative is connected to positive. This negative is connected to positive. This negative is connected to positive. It is taking some other path. Don't need, delete it. So just, however, it is just connecting there, but it will not look so good. Okay, so we are doing like this. So again, and radiation falling on all cells will be same, because solar panel, you have a solar panel where all cells receive same light from sun. So what I am doing is I am connecting all here. Okay, so just connecting like this. Each and every cells radiant is being connected. Now please, you have to look it here. I am going to show one thing, which is nothing but how to create subsystem. See, if I go on connect like this solar panel, go on connecting cells in this page, it looks so awkward. So we will not do so. Rather, what we will do is just try to collect all, then press right click, create subsystem for selected item. Just if you do it, you get a block like this. Okay, so this is a subsystem now. This subsystem consists of 6 solar cells. Okay, then you have this person called as gradient, through which you are going to connect about whether what type of radiance you are going to connect. There is one more 2 things. See, again this is not nice. One is on left hand side, another one. So what you will do, double click, leave this fellow, click on this fellow, left click, then where it should be visible, it should be visible on right. Okay, that is right. Now click it here, it is showing left. Now what you have to do, change it to right. So if you change it to right, now you come and see what is the difference. The difference is the 2 outputs have came in the right hand side. So now this is positive, this is negative. Now what we can do is simple, just again right click, drag. See, now you are able to get each and every subsystem. So this is 6 directly you are multiplying. Now it is very easy for us to do. So 10 you can, if you connect 10, it will become 60 cells. So approximately we will connect around 12, so that if you connect 12, it will become the required solar cells. Okay, so I have already simulated and kept it, so I will go there so that you can understand. So here, this is the block. Just when you to view it, what you have to do is go to, you have to just right click it, then mask, then you call it as look under mask. So now can you see? So now under each thing you will have solar cell. So inside this we have connected solar cell, we have made it as a subsystem. Then on that subsystem we have interconnected. See, negative is being given to positive. Again this negative is connected to positive. So only it will become series. So connect all this thing. So once you connect all this, you get the entire setup now. And this setup is in SIMscape. So this SIMscape cannot be connected directly to this block. Is nothing but a constant block. I will show you. Go to this simulink, commonly used block set. Commonly used block set, you have a person called constant. This is what being used there. Okay, this is what being used here. Both are same. Just here it's showing 1000 because I have told sun's rays is 1000. So we are entering the value as 1000. Just how you have to enter, just left click it, a screen will pop up. On the pop-up screen you have to enter. Okay, once if you enter 1000, then you can connect it. This block I have told you, this block is available in, I will again repeat, see 1 or 2 times if you try to listen, then you will get by hearted. See, we have a sound knowledge or we have vast experience. So our experience, we will directly know where to go and find. So again I will repeat, it is there in SIMscape utility. Last under SIMscape utility, there you have PS to S and S to PS. Okay, so that I have connected. So I am converting simulink block into PS block, SIMscape block, and giving it as input. So I have given input to this fellow. One thing I have told you is for each and every system you have a separate solver. See, for this I am using one more solver. This solver is called as FX0. Where is this solver is? Again this, this solver is again in Simulink browser. When you go here, in utility, same utility, you can see this solver configuration. You just drag it and place it. So just you place it here, which is already in placed. So just to show you, I have brought this, you can delete it. So now what and all I have done, I have prepared my solar panel. So entire solar cells are combined, and this is called as solar panel. Here you can write, if you want any content you can write, or even you can put your image also here. So solar panel image also you can put it here. Now solar panel setup is okay. Now I am going to test my solar panel. That is my second step. Testing means I have to see what is the power, what is the V, what is the I am obtaining. So what for this I have to connect a load. So the load which I am connecting here is the person who this is called as a variable load. At the runtime, automatically this load value will change depending upon what you are giving. So I am giving a ramp. Ramp is nothing but initially it will be 0 and finally it will reach 1. Okay, that I am connecting to S to PS. Again I say this ramp is being taken from Simulink browser, where in Simulink you have a person called source. In the source you have a person called ramp. So I am taking from here, so I cannot directly connect. So I have to connect via S to PS. So I am connecting via S to PS to this variable load. Again this variable load is in SimScape. Then comes your, I have to measure V and I. That V and I, what I am measuring here is different from what I have measured in boost converter, because that is on SimScape. This is from Sim Electronics. It is another block. So separately I have to go and select this. So where to go? Just you go to Simulink browser. In this Simulink browser, you come to Sim Electronics. In Sim Electronics, you have a person called sensors. In that sensors, you have this voltage sensor and current sensor. Okay. 1 minute, I will show you. You just write it here as current sensor. Okay. So if you write current sensor, it is here. Okay. It is in SimScape. SimScape electrical. Under electrical, you have electrical sensor. When you want to see here, it is electrical sensor and voltage sensor is there. From here, you have to take your both current and voltage. So that I have connected here, current sensor and voltage sensor I have connected. So now for to test the solar panel, what and all you have to do is you have to draw a graph between V and I. You have to draw a graph between power and V, and you have to draw a graph between power and I. All this graph you have to draw. So to draw that, see what I have done is, since this is a DC, to get the power, just to multiply V into I, you get power. So that is being done with the help of this product block. Where it is this product block is, again I will tell you, in commonly used block set, go to Simulink. In Simulink, commonly used block set, if you go, there is a person called product. It is here. Okay, this block only I have used. So that block is here. Now can I simulate it and show you? Just press simulation. Yeah, once you do this, it will compile. So it takes some time now, because since it is little bit big circuit, so it takes some time. So once there is thing, what you have to remember is this X and Y plot will appear. So in that X and Y plot, see now it is showing a graph between V and power. So this block is, so this block you are able to see that there is graph between power and voltage. So this is your power and this is your voltage. So why you want to see this? So when you operate at 24 volts, this will be the power, okay, around 250 watts when you operate in 24 volts. That is why in presentation we have shown your this particular 250 watts panel. In 250 watts panel, not supposed to multiply 37 and to 8 and say that is going beyond 2 watts. No, 250 watts is obtained only if you operate the fellow in 24 volts. So that is very clear from this graph. So this graph, what it is showing, see at 24, this array is 24. When you see is 24, it comes around 250 watts. So that is the operating. So that is where the region where you can operate. You cannot say, sir, I have brought a solar panel. Solar panel specification says around 37.25 volts, sir. So what will be the power? So you have to simulate it and try to find. So once if you only simulate it, then you will come to a conclusion that what should be the power which I am getting. So that is why I have shown a graph between power and V, so that you will be clear. And the next graph is between V and I. This is also plays a major role. See, currents remain constant. They 2-mark question, even they will ask, give an example for constant current source. Only device in till now we have a person who is always capable of delivering a constant current is only solar panel. Solar panel alone can deliver a constant. See, when the voltage is 0, 10, 20, 30, 40, till around 30, around it is operating able to give around your constant current. Now you are going to operate only in 24. So 24 into around 8 point, around 9, it will give you your 250 watts. Okay, so that is what the simulation of solar panel. So this is the simulation of solar panel. Again, sir, you are showing with respect to XY graph. Shall we again do as usual what you told by plot? That is also possible. See, this is your value. Go to history. I have ticked it. I have written as SI. So directly you can type SI and you can see your graph. What graph? This is graph for current. Similarly, this is graph for your voltage. See, this scope is for voltage, scope 2 is for voltage, scope 1 is for current. Say, okay, so now how to draw? Go to command window. Here I want to draw a graph between voltage and current, but I doesn't want a time. So what I will do is, this part I will remove. So I will remove this part. Time is not at all required for me. So I will directly remove this value. Now this, what is the value? It is saved there. Just I have forgotten. Just I will, once I will go back and I will see income. Voltage is saved as, current is saved as SI. So it might be saved as SI and SV. So come to command window. You have to write it as SI is for current. So capital S, capital I. Here you have to write it as SI and SV. Then press enter. If you press enter, you will get in figure. This is what between current and voltage. So now we have ulta. What ulta we have done is, we have taken current on x-axis and voltage on y-axis. That you can change. That is not a problem. Just go to command window. See, don't need to type again and again. Just press up arrow. When you press up arrow, automatically your what and all you have typed till now in your command window, we can visualize. Okay, so now I have to interchange this. So copy this, Control X, then paste it here, Control V, then put a comma, space. That comma you try to remove, the comma which we have placed here. Now put enter. So now your graph gets changed. So now x-axis has become voltage and y-axis has become, and similar way what I have told, you can put X label. So X label here is not your time, now it is voltage. So voltage within bracket you can write it as V. Okay, so similarly you can insert X label. So we have inserted X label. So go for insert of Y label. In Y label it is nothing but current. So write it as current within bracket. Units are more important as far electrical is concerned. So you have to write it as current in terms of amps. Okay, now you can give even title which is going to say about it's a graph between voltage and current. So you can write it as voltage plus current. You don't want to even put capital for V plus, so you can change it as small letter. So finally again I told no, you can just save it. So further case you don't want to again and again. So I will say I will V now you will have a doubt, sir. Okay, you are saying that we are able to understand. So what you have to open, now I am closing the figure file. So just I am going here, just I am closing this figure file, and even I can close that Matlab file itself, the file which we have with the solar PV. So even this I am closing. So I have closed it. So you don't have a figure file, you don't have your simulated file. Okay, now you go here, go to command, just say open, go to the place where I have saved in desktop, go here, just press on this and open. Now automatically this file will open. No need to have any simulation background file at all. So directly you can open and you can alter and you can use it in your paper or wherever you want. So that is the advantage of the command plot. Okay, that is the importance of the command plot. Okay, now I think that we are running out of time. So that now let us, sir, I can continue till 5:30, sir.
Yes. Yes, Vinod, 5:30.
Yes, 5:30. Yeah, I can go till 5:30 now, sir.
Yes.
Yeah. Okay. So now we have seen about the simulation of solar panel. So solar panel we have simulated. Then what we have done is we have seen the block and all, output, voltage waveform, power waveform, current waveform we have seen. Now I am going to interconnect this two separate fellow which is been simulated. I am going to interconnect. Okay, so now only the picture come into picture that you have already simulated a boost converter, but this boost converter you have simulated with the voltage source, not from solar panel. Now what I am going to do is, now I am going to interconnect this two circuit. So what I will do, let us go to Matlab file. I will show you. So come to Matlab file. So here this is I have already done and kept it, because one problem with Matlab is it takes more time to simulate and run. So that just to reduce the time, I have done it. The thing you have to note, very important thing which you have to note is the output from the solar panel you are taking from SIM electronics or SIMscape, which is when you want to give it to your boost converter, you first convert the take the voltage, convert it into PS to S, that is from SIMscape to simulink. But this converted output is a signal, not as a value. So from the signal you have to convert it into voltage source. So only I am using the block called controlled voltage source. This again I will tell you where it is. It is in, you come to SIMscape, in source we see, sorry, this is SIM electronics, SIMscape you have to. So this is SIM power system. In SIM power system, this block is there, controlled voltage source. Take this fellow. So this fellow has a capability of converting signal to voltage. So this signal is converted into voltage. So now you have plus minus. I am bringing to this subsystem. I have shown you how to create a subsystem. This is also a subsystem is being created. Double click. So this is what the converter we have done initially. So a converter what we had here, we had a source. We have connected battery before. Now what we have done, we have connected a DC supply here. Now we have replaced the DC supply by source. So see here, this is the two terminal which was there, where you connected your control R. Okay, this how it was there. Okay, I think you all know this how it was there. In between this was you having a DC source there. So now what I have done, I have removed it. Instead of DC source, we are going to give from your photovoltaic cell or PV cell. Okay, and again similarly I am taking output outside. So that is what inside this subsystem is. Why we usually create a subsystem is, when you put a paper or when you are publishing anything, we will not expose all the content. So what we will do is, we will usually hide the content. To hide the content, we will always go for a subsystem. Just we will make it as a subsystem and we will just write the name here. Okay. So this is solar panel. I think again I will show what is there inside. So that how to see inside a subsystem is, go to right click, go to mask, look under mask. When you look under mask, it will show the solar panel. So see here, they have connected so many in series, each has internally you have solar cells. Okay, finally this what we have seen. Now I don't want to put load here because load should be at the end, far end. Always load should be on the last side. So I have removed the resistor and all, which I have connected here, variable resistor. Variable resistor I have connected here just to identify the graph for V and all that is been removed. So just I have connected a V sensor, I sensor. I is also not required now. Only V is required because voltage, this requires input voltage. So I have connected a V voltage sensor. See again what I have done here, sir. You can ask, sir, we are unable to see what the name of this block. So right click, go to format, show block name. If you write, then it will come current sensor. Usually again for some reason we doesn't want to show what is the block name. So what we will do is we will go to format, we will remove. So once you remove that show name, the name will not be shown. So it will be just appearing in your simulation file. Okay. So now it is AV. Now what I am going to do is I have connected a boost converter. So now I am going to see the graph. So you all know that your output is around 45 volts. This 45 volts is now taken and given as an input to this converter, and converter output you are able to see. Now simulate. Again it will compile. So once compiling is over, you have to wait for compiling. It takes some time. Since circuit is big in size, it will take some time. It will compile. Once it has compiled, see it start running. Matlab is a big ocean. I think for me, if you give even 2 to 3 days, then it will not be sufficient to explain you. But I try to explain you. Whenever you have any doubts or queries, you can directly you can contact Professor Dr. S. Nagarajan sir. So sir will give about any details if you want. Sir will give my mobile number or mail ID, or even you can use in YouTube. I am going to upload this what I have taken, all thing I am going to upload in my YouTube channel, and I will share you the link so that you can, with that link you can view it in all this in YouTube also. Everything what I am presenting today is already been uploaded in YouTube. Today afternoon only I have uploaded, so that you can go and view in YouTube also. Even if you have doubts, you can comment there. See, at one shot you cannot learn Matlab. Sir, you may end with so many errors or any doubts. Don't hesitate. At any point of time you can ask me, because when you ask, then only we will go on and look it, and even that will be an experience for me, so that I can go up in learning more and more. Okay, because Matlab is a big ocean. It is not as compared to other software packages. This is a very huge volume of area where we can go and work. So you will get so many doubts. Don't worry, at any point of time you can ask the doubts, so we can clarify it. So again you can see here, see I'm giving so many talk just to pass the time. See, it is now only started simulating, that is why I'm saying. So see, now you can see there are two solvers in this simulations. Simultaneously I have used one solver for SimScape, that is solar photovoltaic, and another for boost converter I have used power GUI block. So both the blocks I have used here. Again power GUI block I have told where it is, so you have to pick and drop here. If you are not putting this power GUI block, it will show some error and it will not simulate. Okay, so I think now you can see some part of the waveform. It has come around now itself around 260, 270 it is boosting. So input voltage is being boosted. So we will just wait for some time. I think it will settle in once 260. So once it settle in 260, we doesn't want to waste time in simulating. We will just stop it and we will see that how you are getting the waveform. Okay, it is just to say that you are boosted, your input voltage from photovoltaic is being boosted. Okay, so after this what you have to do is there is no load, DC load available for us. So obviously we have to go for an inverter circuit. So that is the last topic of our presentation. So you can see here it starts from 0 and it has reached around 250. Okay, if you go on proceed the entire simulation, then you will get a nice graph. that I will show you now in the PPTs, okay, so that you can go a little bit fast. So this is how you will get. So I have again plotted between input and output. This is your output of solar panel and input of the boost converter, which is being boosted here. So from around 45 volts to around 250 volts, it has been boosted. So you have got, now what you have got, from the solar panel you have got the output. From the solar panel I am giving it to boost converter and getting my output. Be very clear always, voltage increases, obviously current will come down because power have to remain be constant. So when you measure power here, current here and current here, you can visualize here you will have more current and here the current will reduce. Okay, how to measure I will just tell you, you can do it and see. Okay, just what you have to do, you have to put a scope here, similar scope here, you have to put a scope. Directly you cannot put a scope because this is in SIMscape. So obviously you have to connect a person like this. Okay, then you have to put a scope here. So when you have to put a scope here, then you can see what is the input side current. Okay, again here to see this current, what you have to do, you have to cut it because I have told current should be always measured in series. So go to measurement, in measurement try to take current measurement, add this to this circuit. Now add this current measurement here, where you have to add, you have to cut this and then add. Okay, I will just move it so that you can see it clear.
No response.
Discussions are good.
Already we crossed some plus. Registration will come, sir. Only thing whether they are coming for webinar or not, that is important.
So I have to measure current in series.
Whenever we post,
so I have put current in series now. So you can measure current here. See, this is just.
Even for that research methodology Saturday, we have received 1,200 plus.
Okay, now again you have to put a scope here. So you put a scope here.
Sri Lanka.
Now what you can do, if you run for again for simulation, you will get input current and output current. So just go here, go to history.
Standard time.
This is input current or current from solar. So you write it as a solar, solar I. Solar I. Okay, apply.
Yeah, just some common topic.
Similarly, here you have to write it as boost converter current. So you write it, go to history. You write it as converter. So CONI. Apply. Then you try to again simulate it. Okay, when you simulate it, you will get both current. It is showing because I have left it open. Okay, so it is showing that you have not connected a negative terminal at all. So try to do that. It is showing. So what you have to do is connect negative here and positive on the top. See, Matlab will try to tell you then and there. If there is any error, it will tell you. So once if you correct it, automatically it will accept it and it will show you your waveform. Now again it is compiling. So once it finish compiling, it will show you that error will vanish. Till that time it will indicate. Now it get vanished because now that I have connected, so that error will not come. And now again it is simulating. We cannot wait till for huge time. So I will put it as just some value of 0.5. Simulation I am running for 0.5, but 0.5 itself will take a huge time because it is very huge file. So it may take some time. So even you can try this circuit so that you will get it. So little I try to complete. So next is DC. We cannot directly use DC. So what should you do is we have to move for a person called inverter circuit. Inverter is nothing but converts DC to AC. There are so many types of inverters available. That is, we call it a square wave. With respect to wave, I am saying, with respect to wave shape, we call it a square wave, sine wave, modified sine wave, and so on. So let us start with a basic inverter circuit. With the basic inverter circuit, we all know that you have 4 switches. So 4 switches and you have a DC. In our case, this DC will come from buck boost converter. Here it is with the normal. If you, since time is not there, I can go to our circuit, where in our circuit you can clearly see that you have a solar panel. From the solar panel it is being given to boost converter. From boost converter I have given to an inverter circuit. The inverter which we use is sine PWM inverter is there. Sine PWM inverter, the output will be, see, initially the width is very less, is gradually increasing. At the center part it will have maximum width, and again it will come down. So this is just, I am showing here one cycle of your waveform. So this is what the entire setup, and this will be your output, inverted output. So from the solar you have taken, you have boosted is being given to the inverter circuit. So this inverter circuit output will give you, you can connect it to the load. Okay, for an example, if you have an office which starts from 10 a.m. to evening, working for evening 3 to 4, why you want to depend on EB? Rather, what you can do, you put a solar panel on the rooftop. So by 10 a.m. the solar panel will start developing the voltage and current. You try to give it to a boost converter, operate, boost it up to the required value and then give it to an inverter, and you will get an AC, single phase AC supply. Directly you connect it to your lights and fans. So what happened? You don't want to have EB. So that is why we call it as, it is a green energy. Okay. So thank you for giving me this opportunity to present before you.